Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we will look at the OR rule for probability. It's called the OR rule because we're finding the probability of A or B. Remember, this means union. We read it as OR. So why is this result so? Well, let's look at a Venn diagram. We know that A or B includes everything inside these circles. So the probability of being inside these circles, we include everything that's in A. So that's A. We include everything that's in B as well. But notice I have shaded this area twice. I've shaded the intersection twice. That's why I need to subtract it, because I've double counted it. So the probability of being in A or B is just the three numbers inside the circles added up over the total, all four numbers added up. So the problem is, if I do A and B, I would end up with 2Ls. I've double counted this. That's why I need to subtract it. This is A. This part here is B. I need to subtract an L. I need to subtract what's in the center because I have double counted it here and here. That's why the rule works. All right, let's now look at applying it. So I pick a card from a normal deck of 52, calculate the probability that the card is a queen or spades. So remember, whenever we look at the word or in probability, we're including the case that it's both. So this card could be a queen, or it could be spades, or it could be both. So using the OR rule, we have probability of queen or spades is equal to the probability that's a queen plus the probability that it's spades, and then I need to subtract the probability that it's both. So in a normal deck of 52, the probability of a queen is 1 over 13, or 4 out of 52. There are 4 queens in the deck, 52 cards in total. So what about the probability of spades? Well, in a normal deck of 52, there are 13 hearts, 13 diamonds, 13 spades, 13 clubs. They're called suits. There are 4 suits: spades, diamonds, hearts, and clubs. So the probability of picking a spade is 13 over 52, or 1 over 4. The probability of picking a card that is both queens and spades. Well, there is one such card in the deck, which is the queen of spades. So I need to subtract 1 over 52. So I can just put this straight on my calculator, and what I should get is 4 over 13, or 16 over 52. Basically what happened, there are 4 queens in the deck, 13 spades. So 4 plus 13 is 17, and then I took away the one card that is both. 4 plus 13 minus 1 is 16. There are 16 cards in the deck that are queen or spades. 16 over 52 simplifies to 4 over 13. All right, let's now look at mutually exclusive events. So 2 events A and B are said to be mutually exclusive if the probability of A and B equals 0. That means 2 events A and B are mutually exclusive if they cannot happen at the same time. So example would be getting an A in maths this semester, getting a B in maths this semester. They are mutually exclusive because you can't have both at the same time. You can't get an A for your semester grade and get a B for your semester grade at the same time. So that's what this means. They can't both happen. So our OR rule from the previous page was this. But if A and B are mutually exclusive, then this probability of A and B is 0, so it just goes away. So if 2 events are mutually exclusive, the probability that either happens is just the sum of their probabilities. Now this sounds and looks a bit complicated, but you would have been using this in probability without thinking. For example, if you roll a normal 6-sided die, the probability you get a 4 or 5 is just 2 over 6. The probability you get 4 or 5 is just the probability of a 4 plus the probability of a 5. So that's really straightforward and commonsensical. Let's look at a slightly harder example. So again, we're talking about rolling a normal 6-sided die. A is the event I roll a multiple of 3, B is the event I roll a number less than 3, and C is the event that I roll an even number. So let's decide whether these constitute mutually exclusive events. So it's sometimes helpful to write out the possible outcomes if there are not many. So A is the event of rolling a multiple of 3. So A can happen 2 ways, if I get a 3 or a 6. So B is the event I roll a number less than 3. Well, note 3 is not less than 3. My only possibilities for B to occur are 1 and 2. And of course for C, rolling an even number, I could roll a 2, a 4, or a 6. So we can see from that A and B are mutually exclusive. That's because you can't have A and B happen at the same time. If you roll a die, you can't get a number that's a multiple of 3, but also less than 3. Because B can only happen if you get a 1 or a 2, A only happens if you get a 3 or a 6. There is no overlap between these two. That's why they're mutually exclusive. So the probability of A or B, probability you roll a number that is a multiple of 3 or is less than 3, is just the sum of their probabilities. Probability of A is 2 over 6. Probability of B is 2 over 6. So 2 over 6 plus 2 over 6 just gives you 2/3. So when you have two mutually exclusive events, the probability that either happens is just their probabilities added up. So let's look at the other combinations. B and C are not mutually exclusive. Why is that? Because you can have B and C happen at the same time. If you roll a 2, you have rolled an even number, and you've also rolled a number less than 3. So B and C are not mutually exclusive. What about A and C? Well, you can see again they're not mutually exclusive because you can have A and C happen at the same time if you roll a 6. If you roll a 6, A has happened, you've rolled a multiple of 3, and C has happened because you've rolled an even number. So for two events to be mutually exclusive, they cannot both happen at the same time. If there is even just a small chance that two events happen at the same time, they are not mutually exclusive. If events are mutually exclusive, you can use this rule. If they're not mutually exclusive, just use the OR rule on the previous slide. All right, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.